This is part 2 of lecture 6 and is a continuation of our discussion from part 1. In part 1, we discussed how we can overcome one of the limitations of the difference amplifier, more specifically the low input resistance of difference amplifier. In this part, we'll see how we can overcome another limitation of difference amplifier, that is the low gain. In other words, we'll see how we can enhance the gain of the difference amplifier. Improving the gain, how we can improve the gain of the basic difference amplifier. First, take a look at the circuit that was developed in an attempt to enhance the input resistance of the difference amplifier. So what was done? Uh, Two voltage buffers were added at the input of the difference amplifiers. The voltage buffers, they provide ideally an infinite input resistance. So when you apply a signal, in this case the Vs, with a source resistance Rs, when you apply this signal to the difference amplifier through the voltage buffers, no current will be flowing in the circuit because the voltage buffers, they provide an infinite input resistance. So at the input, circuit is basically open, and since there is no current flowing, there is no voltage drop in the source resistance Rs. And so the voltage here VID, which is the difference between V2 and V1, will be same as the signal voltage Vs. And the voltage buffer, since the gain is 1, the whatever voltage you have here, the Vs, the full of it will be transferred to the output side, or what is the input side of the difference amplifier. So at the input of the difference amplifier, you get the full signal voltage Vs without any loss. So that is how we overcame the limitation of the low input resistance of the basic difference amplifier by adding the two voltage buffers at its input terminals. But the voltage buffers, they do not provide any gain. Their gain is just 1. So how we can improve the gain of the basic difference amplifier while we maintain the very high or ideally infinite input resistance? That is not that difficult. That is actually pretty straightforward. We can just convert these voltage buffers into uh, a non-inverting amplifier. As you know, the non-inverting amplifiers, they also have ideally infinite input resistance. So you just add the two resistors in the negative feedback uh, part, the inverting input terminals, and you can convert this into amplifiers. So you add the gain while you maintain the infinite input resistance. So once you have converted this into amplifiers, the circuit that we'll get will look like this. So you see now the voltage buffers we have converted into non-inverting amplifiers by adding these two resistors R and RF in the at the non-inverting input terminal. And you see that the input is applied to the R and RF are applied to the inverting input terminal, and the input is applied to the non-inverting input terminal, and we still have this infinite input resistance. So now this amplifiers, the non-inverting amplifiers, will add a gain. So voltage here V01 will be amplified form of V1, as well as V02 will be amplified form of V2. So now what will be the overall gain? So we have converted the voltage buffers into non-inverting amplifiers by adding these two resistors R and RF, and the overall gain now we can express like this: V naught by this difference between the two input signals, V2 by V1, and that we can break up into the product of two gains. One is this the first part, V naught by V02 minus V01, that is the difference between these two voltages that is coming at the input of the difference amplifier, and the second part is this difference voltage here divided by the difference voltage that is actually applied at this the non-inverting amplifier input terminals. So the voltage, the gain is now expressed as the product of two gains, and these two we can consider the first one, the difference amplifier at the output side, that is the output stage, so that is the gain of the output stage first part, and the second part is that this is our input stage, and this one, the factor here, gain factor, this is the gain basically of this input stage, and that we can also call the gain stage, and the output stage is our the basic difference amplifier. So now we'll try to derive an expression for the gain of the modified difference amplifier circuit that we came up with in our previous slide in our effort to enhance the gain. The circuit that you can see it here has two parts. One is the input side that we call the gain stage that was added to our basic difference amplifier, and that is now the output stage. The overall gain, as we have shown in our previous diagram, we can express as the product of the two gains. One is the gain of the basic difference amplifier, other is the gain of the gain stage. The gain of the basic difference amplifier is already known to us, that is R2 by R1. Now the question is, what is the gain of the gain stage that we have added to our basic difference amplifier? So that is the gain that we are trying to determine, V02 minus V01, the output of the gain stage divided by V2 minus V1, that is the input of the gain stage. Now you see that these two are the non-inverting amplifiers, and the gain expression for both of them, the gain for the first one, V01 by V1, V01 output, V1 input, and then V02 by V2 for the second amplifier, V02 output, V2 input, and the gain is 1 plus RF by R, that is our well-known gain expression for the non-inverting amplifier, which is same for both the amplifiers. So the output V01 we express as the gain times the input V1, and V02 the gain times input V2. Now if you take the difference between these two, the V02 minus V01, so we get this expression from these two. So that's the gain, common gain, times V2 minus V1. Now rearranging the terms of this equation, so if we divide this by V2 minus V1, you finally get this expression. So that is the gain of our gain stage that we have just added to our basic difference amplifier. So that is how we have determined the gain of the basic difference amplifier. Now that we have determined the gains of the individual stages of the modified difference amplifier circuit, we can determine the overall gain of the circuit. The overall gain, as we have expressed in our previous slide, that it can be expressed as the product of the two gains. One is the gain, that is the gain of the difference amplifier, the output stage, and that is the gain of the gain stage, that is the input stage. So the gain of the difference amplifier, the output stage is R2 by R1, and that is the gain of the input stage or the gain stage that we have just determined. So that will be the overall gain of this circuit. And so with this modified circuit, we have now successfully overcome the two of the limitations of the basic difference amplifier. One is the low input resistance, because the inverting non-inverting amplifiers, they provide ideally infinite input resistance, and they're also providing the gain. So the overall gain is now the product of two gains, and we can easily achieve very high gain with this new circuit. But now the difficulty that remains is the third limitation, that is the difficult to vary gain, that is still there, because if you want to vary gain, you have to vary either of these there are four resistors, and you need to vary any of these four resistors. So you see that it's not possible to vary the gain with the difference amplifier part, that for either R1 and R2, both there are two of those. And for the gain stage, you are either vary R and or RF, and you see that we have two R's and two RFs. So that difficulty still remains, because you need to vary, if you want to vary the gain by varying R, then you need to vary these two R's at the same time. Or if you want to vary the gain by varying RF, then also you need to vary these two RFs together. So that difficulty remains there, as we have mentioned before, that it is very difficult to vary the two resistors while maintaining the same value for those two at the same time. So the third difficulty still remains, and so next we'll see how we can overcome this difficulty in varying the gain for the difference amplifier.